Hello, ladies and gentlemen. Today we are going to learn about the reason that we care about factoring, or the reason that factoring becomes very useful to us. So today we're actually going to solve using the process of factoring. So you need your notes, something to write with and a calculator. Make sure that you have the note divider page in there, kind of dividing this first unit or this unit here on solving quadratics. This is the very first way that we can solve. Factoring is a tool that we can use to help us solve. So this is the first thing I need you to write in your notes today. It's called the zero product property. And I know it's a lot of writing, but basically it's talking about how we can use factoring to solve. So in words, if the product of two expressions is zero, then one or both of the expressions is going to equal zero. So basically what we're saying is if A and B are expressions and we have A times B, then we know either A or B is going to equal zero. So what this means in terms of our factoring, so in words, this is what it says. In algebra, you might see it written like this, but it means in terms of our factoring, if we have two factors like x plus 5 times x plus 2, and they're both equal to 0 here, or they're being a product being equal to 0, then we know that one or both of them has to be equal to 0. So we know x plus 5, this factor, should equal 0, or x plus 2, the other factor, will equal 0. And that means that I can then solve each of these two little mini equations to find my solutions. So let's see this in action here, how factoring will help us exactly find these solutions, okay? So here's our first example. We first need to factor this guy and then use factoring to help us solve. So we have x squared plus 9x equals, or plus 14 equal sign 0. So we're going to focus on factoring this part right here. And to do so, we're going to use the AC method because this is in fact 3 terms. So remember with the AC method, you take the number in front times the number in back. So 1 times 14 gives me 14. And then we ask ourselves what multiplies to make 14, but would add to make the middle guy number 9 here. So we would say, 14. Well, that's 1 times 14, 2 times 7. We want the pair that adds to make 9. So that'd be 2 and 7. Now I'll rewrite this problem with the x squared, the 2x, the 7x, the 14. And it's still all equal to 0. Now, once I have it rewritten in 4 terms, I'll do the same thing I was doing to factor here. I'll group. So what can I take out of those 2 terms? I can take an x out, leaving me with x plus 2. What can I factor out of these 2 terms? I can factor out the number 7, leaving me with x plus 2. So what do I have here? My 2 factors are x plus 2, oops, and x plus 7. Equal sign 0. So now, kind of want to rewrite this a little better here. There we go. So now I have 2 factors equal to 0. That means that when I'm dealing with these 2 factors, that both of them need to be set equal to 0 and solve. See the step down here? Once I have it factored, I'm going to set each factor equal to 0 and then solve. So I'm going to take the x plus 2 factor and set it equal to 0. Well, what would I get if I solved that? I'd subtract 2, x would equal negative 2. I'm now going to take the x plus 7 factor from above and set it equal to 0. Well, then I could subtract 7, x equals negative 7. Look at that. I ended up with 2 solutions here. One of them is a negative 2, the other one is a negative 7. Factoring allowed me to break apart this complex equation, or in this case just the right or the left side here, this expression, break it apart into 2 smaller little factors that I can then set equal to 0 and solve easier problems then, rather than dealing with the whole complex one. Okay, let's look at another example here. First, we're going to factor it completely, then we're going to set each factor equal to 0 and solve. So what do I have here? I have another 3-term problem, 4x squared, 22x plus 10. So before I go into the AC method though, remember we always want to check for a greatest common factor. Do you see how all of these are even numbers? That means they all can be divided by the number 2. So I'm going to factor out the number 2 first. This then becomes 2x squared, this becomes 11x, and 10 divide the 2 out becomes 5. So far I'm here. Now that I factored out that 2, now I can do the AC method. Now 2 times the 5 becomes 10. What multiplies to make 10, but would add to make 11 in the middle? 10 and 1, right? So I'm just going to rewrite this part of my problem here as 10x plus 1x plus 5. Okay, that 2 is still hanging out in front. Now I'm going to group this middle stuff. So I'm going to factor by grouping here. What can I pull out of these two pieces of my terms here, these two pieces of my equation? I can take out a 2x, leaving me with x plus 5. What can I divide out of these two? I can divide out a 1, leaving me with x plus 5. So my two factors here are x plus 5 and 2x plus 1. And don't forget that 2 that we took out right away in the beginning, he just pops down and sits down in front. Now that I have it completely factored, I set each factor equal to 0 and then solve. So let's grab this x plus 5, set it equal to 0. What's my solution? X would equal negative 5, right? If I subtract that 5 over, I'd have negative 5. And I do the same thing with the 2x plus 1. 2x plus 1 equal to 0. If I solve this, careful, I'm going to subtract that 1. 2x equals negative 1, x equals negative 1/2. Yep, I got a fraction. That's okay. Now I have those two answers. Now what about this 2 in front? This guy, if I set that equal to 0, there's no x to solve for here. In fact, 2 doesn't equal 0. If this was 2x or 2 plus x, we could go ahead and solve that. But this just says 2 equals 0, and that's not true. So that's not going to give us a solution. The two solutions we got were from the x plus 5 and the 2x plus 1. They both led us to solutions of negative 5 and negative 1/2, okay? So when I have a squared in my problem, I need to make sure that I have two solutions when I'm done solving. Let's do one more. Example 3. So again, we need to factor here and then set each factor equal to 0 to solve. What's weird or different about this one is that you have x squareds on one side, x's and numbers on the other side. Remember, we want to get it into standard form on one side. So that means you want to make sure all the terms are on one side. It's easiest if your x squared here remains positive. So even though it seems like more work, I would want to subtract the 9x and add the 8 over to the other side. 0 will be on this side, but that's okay. I'll have x squared minus 9x plus 8. Once I have them in standard form with the x squared positive now I can go ahead and factor. So in this case, I'm going to again do the AC method because I have a trinomial, 3 pieces, and that coefficient in front is a 1. There's no greatest common factor for me to take out here. So I'm going to go ahead and multiply a times c. 1 times 8 is 8. What multiplies to make 8 but would add to make negative 9 in the middle? Well, 8 can be 8 and 1. It can be 4 and 2. But in order to add to make negative 9, what if these were both negative? They would still multiply to make 8, and they would add to make negative 9. So we're okay there. So I'd rewrite this as x squared minus 8x minus 1x plus 8. And I can go ahead and group now. What can I take out of these two? I can divide out the x, leaving me with x minus 8. What can I divide out of these two? I think I'm going to divide out a negative 1 here, making my x then become positive, and my 8 divided by negative 1 is now negative 8, so it matches the first one. So my two factors are x minus 8 and x minus 1. And I still have that equal to 0 there. Now after I'm done factoring, I set each factor equal to 0 and solve. So I would take that 8, x minus 8 here, set it equal to 0. I can add the 8 over, add the 8 over. I have x equals 8. And if I take the x minus 1 factor and set it equal to 0, I would add the 1 over and I get x equals 1. Okay, so factoring allows us to break apart a quadratic equation here into different little factors that you can then set equal to 0 and solve to reveal our two solutions. All right, I want to thank you for taking good notes. 3 good examples in there. This is how we use factoring. This is why it's important, okay? Thank you, ladies and gentlemen. Kincaid out.